right, hey guys, it's Mr. Kyle, Myers Mathematics, and let's just jump into it. It's been a little bit. I've been busy with, well, teaching, but let's jump into why the derivative and the integral are just the same thing but in reverse. So with a derivative, let's start with the power rule. So what I mean is the power rule, because that's the main rule of both derivatives and integrals. So the power rule, when we say power rule, normally we just kind of like assume that it is talking about a derivative or it's talking about an integral if we already know we're going to be doing one or the other. But in this case, we'll call it the inverse power rule for the integral, or the anti-power rule. You can call it that as well. I think I'll just call it the power rule for right now. So that'll mean that it's for derivatives. And then I think we'll call it anti. I think I like that one better. So the power rule, aka the power rule for derivatives, is basically this. And I don't like writing it formally. So hopefully this way will make more sense than what the book is saying to do. I'm going to try to keep it real simple. Step one, when you're doing the power rule for a derivative, is to multiply by the power. Multiply by the power. And then step two is to take the power and minus 1. That's it. So whatever the power is, you times by it. So you times by the power. It gets multiplied by whatever the coefficient is of the variable, usually x. If there isn't already a coefficient that you can see, then the coefficient is 1, and then it just times by 1 and it's itself. So if, for instance, you're taking the derivative of x squared, then you just times by 2. And then power minus 1. So it'd be 2x to the first power, which is just 2x. All right, so if you're going to do a power rule for an integral or an antiderivative, we'll call it the anti-power rule. So the anti-power rule, anti-power rule. It's basically the same thing, but in reverse. You're undoing it. It's the anti, it's the antithesis, it's the opposite. So if you're going to undo something, you have to undo the last thing first. Like if you ever tried to undo a knot, you undo the knots that are on the outside before you undo the knots that are on the inside. If you're trying to make knots, multiple knots on a string or something like that, as you make more and more knots, the knots that you keep adding are outside of the ones that you made before. And if you're going to undo all those knots, you start on the ones on the outside and you work your way in, undoing what you most recently did, or what somebody else, or just sometimes things just get knotted and you have to unknot them. So you have to do the opposite of the most recent thing. So the opposite of step 2 in power rule, power minus 1, would be power plus 1. So we power plus 1. We're undoing step 2, and then we undo step 1. The opposite of timesing is dividing, so we would divide by that new power. Oh, that is not an O. LOL. Divide by that new power. And if it's already a fraction, it might make more sense to say you're timesing by the reciprocal, but dividing by a number is the same thing as timesing by a reciprocal. So I don't need to alter step 2. You would just, maybe do that instead of dividing by a fraction to save yourself some time. So for instance, let's say we're taking the integral. So for here we were taking the derivative, which turned into that. But if we're taking the integral of, let's say, x squared, and there would be a dx, but it's going to get cut off, so I'll just not write it. The integral of x squared, I would power plus 1 and divide by that new power. That new power would be 3, so it would be x cubed over 3. x cubed over 3. Hopefully you guys can see that. And we can check an integral by taking a derivative, by the way. So if I want to take the derivative of x cubed over 3, then I would times by the power, so I'd times by 3, and then the power would be minus 1. So that 3 comes out, and then I times by it, and then step 2, I do power minus 1. 3 minus 1 is 2. And then the 3 over 3 cancels, and you're left with x squared, which is what we started with before we took the integral. So it's a great way to check your work there. So hopefully that helps. These are the two most fundamental rules of derivatives and antiderivatives. A lot of times they're called integrals other than antiderivatives, but here it makes sense to call it an antiderivative since it's the opposite of a derivative. So hopefully that was helpful, and I will catch you in the next video. Grab the free guide that I have on my website, myersmathematics.com. It's called The 5 Math Mistakes Everyone Makes and How to Avoid Them, and I'll catch you in the next video. Blessings, y'all.